Hello students, and welcome to this lesson on the area of 2D figures. Our objective today is we will derive area and perimeter formulas of rectangles, squares, triangles, parallelograms, and trapezoids using our journal notes and examples. First, let's go ahead and define the perimeter and the area. So our definition of perimeter is that it is the distance around a polygon. And a polygon is just a fancy word for a shape that is made up of straight sides. So it's going to be a shape with straight sides. And so perimeter only applies to those types of figures. Then we also have the area, right? If we have our area, it's the amount of space inside of a polygon or circle. So we're all pretty familiar with these two concepts. Perimeter is a walking distance around a shape, and then area is the space that's inside of a polygon or that circle. So let's start with some of our simple ones that we're already very familiar with. Let's start with our rectangle. So if we're talking about the perimeter of a rectangle, we already know that the perimeter is equal to 2 times the length plus 2 times the width. But what does that mean? Well, my width is my measurement across the rectangle, and then my length will be the height of the triangle in a two-dimensional space. The area formula for a rectangle will be area is equal to length times width. And some alternative ways for me to write this, actually I don't really like this x notation because we use x all the time now. So instead let's use our dot for multiplication. We can rewrite this as A is equal to L times W, just like we saw yesterday. And then if we assign some values here, let's say that W is going to be W will be 7. And then my length is equal to 4. Then if we plug these numbers in, then we get that our area is equal to 28. All right, and again, this is something that you guys should already know. This is more of a review lesson. It's something that will get us into our newer shapes later. All right, let's talk about a square. We already are familiar with a square as well, especially from our activity the other day. So we've got our area is equal to the side squared. So we could rewrite this as A is equal to S squared, and we have S is any side of the square. And let's just say that the side is equal to 4 here. So if we wanted to find the area of this, then we would say A is equal to 4 squared, or A is equal to 16 units squared. And why is it that this works this way? Well, you notice that, well, actually, let's rethink what our side lengths are here. 1, 2, 3, 4, 5, 6, 7. Okay, so this square that we have drawn here is actually 7. So let's go ahead and redo that. So we've got side of 7, and then 7 times 7, that'll give us 49 over here. But the whole point is the fact that I see that for every small box here, right, it has a side of 1 and a side of 1. So what we're really doing is we're adding up all of these little squares that are being made, because a area is units squared. So our units are actually these little squares that we're working with. So if I were to count up the number of boxes in here, I would see that there are actually 49, and the multiplication is a shortcut for that. All right, now let's talk about triangles. So there are three different ways that you can see a triangle. So the area formula for a triangle is going to be A is equal to 1/2 base times height. But sometimes the height isn't all that obvious, and then we can rewrite this as or A is equal to base times height divided by 2. So let's talk about where the heights are in each of these triangles. So here in this triangle, it's kind of obvious, right? The height of the triangle is this leg right here. And then our base will be here. So this is my base. This is my height. In this triangle, our height will actually be the altitude of the triangle. So we'll take this line here, and it creates this right angle, so that's the altitude, but this will be the height as well. And then my base will be here. And then finally, we have a situation like this, where we have this hanging side over here. So our height will actually be along this line here. And what you notice is that in every situation, the height is going to form a right angle with the plane of the base. So just remember, if you see these triangles in these different orientations, this will be how you do it. So if I say that the H is going to be 4, and the base is going to be 6, then when we calculate this, we see that 1/2 times 4 times 6. So we can say 1/2 times 6, or sorry, 1/2 times 4, that'll be 2. So this will become 2 times 6, and this equals 12 units squared. Then if we come over with this other formula and we use the same numbers, what we'll see is that we do 4 times 6 divided by 2. 4 times 6 is 24, divided by 2 is equal to 12 units squared. And as we see, these two answers here that we got are the exact same. So these expressions here, expression number 1 and expression number 2, are just different forms of the same formula. All right, so those are all shapes that we already know and we are very familiar with. So let's look at a couple of shapes that are not as familiar. All right, so trapezoids and parallelograms. So you might already know the formulas for these, but let's go ahead and introduce them anyway. So the formula for the area of a trapezoid is the area is equal to 1/2 base 1 plus base 2 times height. And the way that I can abbreviate this is I can say, because this is a lot to write, is A is equal to 1/2 B1 plus B2 times H. All right, so what are the bases? Well, you notice how we have two parallel lines here in this trapezoid. That's going to be one of the key things about a trapezoid, is that they do have those two parallel lines. Then what we say is that each of those parallel lines represents a base. So this will be base 1, and down here will be base 2. So those are my two bases, are my two parallel lines which exist here. Then my height will be the distance between them. So it's a straight line distance, which means that we're going to treat it as a line which is perpendicular. And so this will be the height. So if we say that base 1 is equal to 4, we say that the height is equal to 5, and then we say base 2 is equal to 8, then our formula will work out like this. We have A is equal to 1/2 base 1 plus base 2. Base 1 is 4 plus base 2 is 8. And then the height is 5. So then we just go through all of our operations here. So 4 plus 8 will be 12. So that's 1/2 times 12 times 5. And then we can do these in any order. So 1/2 times 12 is 6, 6 times 5, and so we get that the area is equal to 30 units squared. It's always very important when we do this area that we get an answer like this, where we say our units very explicitly. So now that we're working with areas, we need to be very explicit about our units. All right, and now we have a parallelogram. The parallelogram formula will be A is equal to base times the height. And we can abbreviate this by saying A is equal to B times H. So what are the base and the height? Well, we notice that a parallelogram is made up of two pairs of two congruent sides. So this side is congruent to this side, and then this side will be congruent to this side, and also, as it is implied in the name, those sides will each be parallel. So the base is we choose one of those parallel sides. So I'm going to go ahead and choose this one because it's at the bottom, and that seems natural for the base. So this is the base. And then the height will be related to the base in that it is the distance from one base to its parallel side. So then this line here is the height. So if we say that the height is equal to 3 and the base is equal to 5, then the area is equal to the base times the height. The area is equal to 3. The base is 5. And the height is 3, and so the area is equal to 15. All right, that's all for today. So let's go ahead and look at our